Okay, so we need division for slant asymptotes because we need to find the quotient. Remember, the slant asymptote is simply the quotient. Now, in this course, the questions should all be only requiring synthetic division. You could technically use long division to find the slant asymptote, but everything should just be a synthetic division problem. So just really quickly remembering how synthetic division works, it only works for x minus a number or x plus a number. Specifically, you do need a 1x in order to do synthetic division. So the first step in synthetic division is to arrange the polynomial from highest power down to lowest power. So again, it should be an L that you're drawing, and you have x squared, x, and then the constant. You need to make sure that those powers are totally in order, that you're not flip-flopping around there. Then once, and in this case they are completely in order, square first and then constant. So we are good to go there. Then we go to step 2. Step 2 is to create this L. Now on my L, I'm going to write the coefficients of the numerator. So here I have a 1, 4, and negative 1. And then to the left of the L, I'm going to write the opposite sign of what I see in the denominator. That is because ultimately we are going to be adding in synthetic division, and we know from our division process that we actually subtract. So this opposite sign is taking into account that we really should be subtracting, but with synthetic division we add. So x minus 1, opposite sign would be a positive 1. So always flip that sign because we are eventually going to be adding. All right, so now what we do is we go through kind of a similar process to long division. What we do is we first bring down this first number, bring down the first number, and then we multiply diagonally. So I always think about there's kind of like a diagonal movement there. So I multiply 1 times 1 to get 1, and then I'm going to add vertically. And when you look at that addition sign, you see that you do have that vertical line in the addition sign. So I'm going to add the 4 plus 1 to get 5. And then I repeat this process, 5 times 1 to get 5, and then add vertically to get 4. Now, the last number that I get is always the remainder. And because it's the remainder, that is going to go over the original denominator. So it's going to go over the x minus 1, and that happens every single time. So you're going to have a plus. This represents my remainder. Everything else is our quotient. To get our quotient, we always take 1 less than that highest power. So that's step 7, where the first term in the quotient is 1 less than the degree of the first term in the denominator. So here I started with x squared, so this is going to be x to the first, and then plus our constant. So we're basically using these terms for those coefficients. So at the end of the day, this is going to become x plus 5 plus 4 over x minus 1. And the x plus 5 is our quotient, and then the 4 over x minus 1, that is our remainder. And as x goes out to infinity, that would be what would go to 0. So if this question had asked for a slant asymptote, we would simply say that the slant asymptote is y equals that quotient. Keep in mind you do need a y equals because you are describing a line, so you need to have an actual equation of a line, and an equation of a line would be a y equals something.